Good morning. Okay, good afternoon, everyone, and welcome to all of you. I'm Kumar Ravi, and I welcome all the students on English Medium Prep by Exampur YouTube. And we are here for the free classes on Supreme Court JCU exam. And today we will study the theory portion of current electricity. Guys, you all are aware of current electricity actually. Okay, you are watching my lecture on video on laptop, either on your mobile phone or any such type of device. Okay, so these things are run by the electricity, and so today we will learn that what is electricity and what are its effects, and how it flows into any conductor, like that. So there are many things to learn. Okay, so first of all, I welcome to all the students on Exampur YouTube channel, and we will also learn that how does the electricity flows. Okay, so Exampur is one of the best and one of the leading online platform for the government jobs preparation. Okay, the millions of students watch our videos daily, and all over India. And we are here on English medium YouTube channel to provide the best quality education for those who don't understand Hindi too much, and we are focusing to provide the quality education free of cost also. Okay, so guys, if you are new at this channel, then please do subscribe this channel, and share this video among all your friends. Put this on your WhatsApp status or on your all social media accounts, so that it can reach to most of the students. Okay, so today we will learn what is electricity, what is electric current, and what are the different headings of this chapter. But before that, I would like to tell you that we have some paid batches also. Okay, those students who are preparing for different government jobs exams, and those who want to study day per day, and by some sequence order, in some sequential order, from basic to advanced level, then they must join our paid batches. Okay, so to join the paid batch, you have to download the application Exampur official Sarkari Nokri Prep application, and then you will have to register yourself, then join that batch or those batches in which you want to enroll yourself, and I'm sure that you will get a lot of benefits there, like live video classes, as well as the some free classes also, PDFs, okay, mock test, everything. So your complete preparation will be boosted up there, no doubt. Okay, so guys, today let's start the topic current electricity. So we will start the topic current electricity. Current electricity. When we talk about the current electricity, first of all, we should know about, yes, first of all, we should know about the basics of electricity chapter. The basics of electricity chapter. Okay, so what are the basics actually? Let me explain. Yes. So, guys, we all know that in this world everything is made of the very small particles known as atoms. Okay, and those atoms, when combined, form a molecule, and those molecules, when combined, form an object or anything. Okay, so here we will discuss about the atomic level, discuss about the atom. Okay, suppose that this is atom. Okay, suppose that this is atom. Okay, now the atom is made of three different particles: neutron, proton, and electron. Okay, so there are three different particles. So there are three different particles: electron, proton, and neutron. Okay, so you first of all we should know that uh, what kind of these particles are actually. So when we talk about electron, electron is represented as small e, proton, proton represented by small p. Okay, neutron, neutron, proton. Okay, and neutron, neutron. Okay, so these are the particles. So these are the particles actually. Okay, these are the particles: electron, proton, and neutron. Hmm. The charge of electron is equal to, we all know that charge of electron is minus 1.6 into 10 to the power minus 19 coulomb. Minus 19 coulomb. Sometimes in your exam, a question is asked that what is the unit of charge. Sometimes in your exams, a question is asked that what is the unit of charge, and at that time we have to answer, and at that time we have to answer that coulomb is the unit of charge. And what is the unit of proton? What is the unit of proton? What is the unit of unit of charge of proton? That is one also coulomb, but the value is same as electron, but the sign is different. 1.6 multiplied by 10 to the power minus 19 coulomb. Okay, okay. Now neutron, and neutron can be written as 0 coulomb. 0 coulomb. Okay. So guys, this is atom, and atom is made of three small particles known as electron, proton, and neutron. Electron, proton, and neutron. Okay. So guys, if we put electron and electron in front of each other, then they will repel each other. Electron and electron, if we put electron and electron in front of each other, then they repel each other. Okay, they repel each other. But when we put electron and proton in front of each other, they attract each other. But when we put proton and proton in front of each other, they repel each other. Okay, but when we put electron and a neutron in front of each other, no force. Okay, but when we put proton and neutron, no force. But when we put neutron and neutron, no force. Okay, so electron and electron, they just repel each other. We can say that similar charge repel each other, because electrons possesses negative charge. Okay, and electron and proton, these particles attract each other, and these particles attract each other like this. Okay, so these particles attract each other like this. These particles attract each other like this. Okay, so these particles attract each other like this. Now this is an attraction force. This is an attraction force, and this is a repulsion force. This is a repulsion force. this is a repulsion force. Okay, so when we talk about the proton and proton, these two particles also repel each other. These two particles also repel each other. Repulsion. Okay, so this is also repulsion. Now, okay, and electron and neutron, no force. Where the neutron is present, there is no force. Okay, so guys, here we can see that opposite charged particles attract each other, but the similar charges or like charges repel each other, or similar charges or like charges repel each other. Okay, so this is the concept behind that. Okay, so we write it as the similar charges, like charges or repel each other, but unlike charges attract each other. Okay, attract each other. Attract each other. So these are the basic things. Okay, now suppose that if we talk about the big charges, then the question arises that how does the big charges are formed? Actually, how the big charges are formed? Okay, large charges or big charges. Okay, so how do these charges formed? Then what is the concept that ये कैसे बनते हैं? Okay, so we will learn here, and I think you are now able to see it properly actually. Okay, so when we talk about any atom, suppose that this is X. Okay, this is an atom, and this atom is represented like this. Okay, this atom is represented like this, like this. Yeah, this atom is represented like this. Okay, this atom is represented like this, and this is Z, and this is capital M. Okay, so this is Z and this is capital M. Now Z, this is atomic number. This is atomic number. This is atomic number. And what is this? And what is this? Actually, this is atomic mass or atomic weight. Sometimes we call it atomic weight. Okay. So actually, what is atomic number? Atomic number actually represents atomic number of any chemical element. Atomic number of any chemical element represents the number of electrons in an atom. Okay, so this is Z is equal to number of electrons. Number of electrons in an atom. Okay, and Z is equal to number of protons in an atom. Number of protons in an atom. Okay, and capital M is equal to number of protons plus number of neutrons. Okay, so this is the formula. Example, calculate calculate number of atoms, sorry, calculate number of electrons, calculate number of electrons, protons and neutrons in 11Na23. In 11Na23, calculate the number of electrons, protons and neutrons in 11Na23. In 11Na23. Yes, tell me. So which is correct? This is current electricity chapter. Okay, and this is this. Okay. Now, so guys, here we can say that this is Z and this is M. So number of electrons. So number of electrons is equal to number of protons always, and this is equal to 11. Okay, number of neutrons, and this will be equal to M minus Z. Okay, M minus Z, and this will be equal to 23 minus 11. 23 minus 11. 23 minus 11. And this is 8. Oh, sorry. 23 minus 11. 20, no, nothing, 12. Okay, so the answer will be 12. It means the number of neutrons in 11Na23 will be 12. Okay, so this one is the correct thing. Now, guys, suppose that if we want to calculate, if we want to find out that what is the charge on an atom or any body that has the positive charge equal to this. Okay, so suppose that now if this is an atom, suppose that 11 electrons and 11 protons. Okay, so this is a sodium atom actually. Okay, now this sodium atom, suppose that now this sodium atom actually now this sodium atom actually suppose that withdraws 1 electron. Okay, 1 electron is withdrawn from this. If 1 electron is withdrawn from this, then obviously 1 electron, it means the remaining number of electrons are 10. Okay, it means suppose that there are 10 electrons and the 11 protons, then suppose that what will be the total charge on this body. Now the total charge on this atom will be equal to minus 10 due to electron. Okay, and plus 11 and this will be equal to due to the proton. Okay, and this will be due to the proton. ठीक, then answer will be equal to plus 1. Okay, so this will be the correct answer. So this will be the correct answer. This will be the correct answer, plus 1. Okay, now suppose that if one electron is added, suppose that if one electron is added, then what will take place? Okay, suppose that one electron is added instead of withdrawing, then the total number of electrons in this atom will be equal to 12, and in this case the total charge will be equal to, and in this case the total charge will be equal to minus 12 plus 11, and this will be equal to minus 1. Okay, this will be equal to minus 1. So we can say that, here, we can see that this is the deficiency, this is the deficiency, this is the deficiency of electrons. Okay, and this is the excess of electrons. This is the excess of electrons. Okay, so deficiency means positive charge and excess means negative charge. Okay, so excess means negative charge. So what will be the correct thing? That deficiency will lead to negative charge. Negative charge. Okay, sorry, deficiency will lead to positive charge. Positive, but the excess of electrons will lead to negative charge. Negative charge. Negative charge. Okay, so this will be correct. So this will be like this. So here we can see that if we have withdrawn only one electron, only one positive charge appears here. If we add the one electron, the one negative charge appear. Actually, the value of charge that appears on any body or on any atom or any molecule, that is equal to the integral multiple of electron. We will, because either we will withdraw one electron or two electron or three electron or four electron, but we will not withdraw 2.5 electron from any atom. Okay, that's why the charge will appear on any body or on any atom that will be equal to the integral multiple of charge of electron, and hence this will be known as the quantization of charge, and hence this is known as the quantization of charge. So q, suppose that q is equal to the charge on any body. Okay, n is the number of electrons or number of electrons, and E is the charge of electron. Okay, so this is the charge on any body. Charge on any body. Okay, but this is number of electrons. Okay, but this is the charge of electron. But this is the charge of electron. Okay, so suppose that charge on any body can never be equal to 1.5 times charge of electron. Okay, so charge is quantized. Okay, charge is quantized. It means charge will be the integral multiplication of the charge of a single electron. Okay, so that's why if someone tell you that the charge on a body is equal to the charge, the half of the charge of an electron, then obviously it cannot be true, because the half of the charge of an electron can never be exist, because the minimum charge a body can acquire, that is equal to the charge of electron. Okay, so the charge is quantized. Here we come to know that charge is quantized. Charge is quantized. Okay, so this is, now suppose that if we ask a question, if we ask a question, a metallic ball bears a metallic ball bears 4.8 multiplied by 10 to the power minus 12 coulomb charge. Okay, what will be what will be then what will be the charge of the body? Okay, sorry, what will be the deficiency or excess, whatever be, of electrons? Okay, so tell me what will be. Yes, tell me what will be. Yes, देखिए, just see here. If we talk about the excess of deficiency of electrons, then we will have to find out the value of n. Okay, because Q has already been given. This is equal. Because the Q has already been given, and that is equal to itna. Okay. So what will be the correct answer? Because this is Q will be equal to n into E, and this is 4.8 multiplied by 10 to the power minus 12, and this will be equal to n multiplied by 1.6 into 10 to the power minus 19. 19. So 1.6 multiplied by 4.8, and this will be equal to 3. Okay, so n will be equal to 3 multiplied by 10 to the power minus 12 plus 15, sorry, plus 19. So n will be equal to 3 into 10 to the power 7. 3 into 10 to the power 7 electrons are deficient or in excess. Note it down. Okay, so this is the correct answer. Now please note down and tell me that you have noted down. Okay, okay, so this is the final answer. Now suppose that if we talk about hmm, 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 hmm. Suppose that if we talk about the electric current, suppose that if we talk about the electric current, if we talk about the electric current, okay, then if we talk about the electric current, then suppose that this is a metallic conductor. Suppose that this is a wire actually. Okay, this is a normal wire which we use in at our home. Okay, this is a normal wire which we use in at our home, and you can see that the plain wire, which is very simple nude wire, if you take, okay, that is actually of cylindrical shape. Okay, so the similar kind of shape we have already taken, and everything is made of the very small atoms. So this wire is also made of very small atoms, and suppose that these are some atoms. Okay, so these are some atoms, and I'm just drawing that. Okay, so these are atoms, and the central part of these atoms, okay, the central part of these atoms is containing the positive charge. Okay, central part of these atoms, central part of these atoms is containing positive charge. Central part of these atoms containing positive charge. Okay, so this will be, 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 this will be. So here this will be the electron. Okay, these will be the two electrons, these will be electrons like this. Okay, so suppose that now we have just connected, now we have connected, now we have connected, suppose that we have connected the two ends of this wire to the battery, and to the negative side and a positive side like this. Okay, so guys, this is a battery. Actually, what is battery? Battery can be defined as the series combination of cells. Series combination of cells. This is a switch actually. In any circuit, if you don't draw any switch, then that circuit can be said to as that this circuit is wrong. But here we have drawn that this is a switch. Okay, so this is the negative end, this is the positive end. Negative end means there are many electrons. Negative means there are many electrons like this. Okay, so there are many electrons like this. There are many electrons. There are many electrons. There are many electrons. There are many electrons. Okay, so there are many electrons. There are many electrons at this terminal. Okay, when we talk about when we talk about uh, when we talk about the current, then we will have to just close this switch, and when we close this switch, these electrons starts moving towards this terminal. Okay, suppose that there are three electrons reached at this point, and these three electrons enter into the these three electrons enter into the wire like this. Okay, these three electrons enter into this wire, and the same time these three electrons moves out of this wire. Okay, and out of this wire, and the position of all these three electrons get vacant, and to fill this position these three electrons also move ahead. Okay, and again the position of these three electrons get vacant, and to fulfill that position, these three electrons also starts moving. Okay, these three electrons also starts moving like this. Okay, so in this way we can see that all the electrons starts moving in the same direction with the same velocity. Guys, when the electrons move with same velocity in the same direction, that then same velocity with the same direction, yes, same velocity with the same direction, then same velocity with the same direction, then what will happen? Same velocity with the same direction, then obviously we will say that the current starts flowing. Current has started flowing. But here we are seeing that the negative charge is actually flowing in this direction. Okay, guys, negative charge is flowing in this direction. It means the deficiency of electrons is flowing in this direction. Deficiency of electrons means positive charge. Okay, so positive charge will flow in this direction. Okay, so guys, initially it was assumed that the direction of electric current is same as the direction of flow of current, the direction of flow of electrons. But after some time, when it was assumed that the direction of electric current and the direction of electrons is same, laws of magnetism were failed. Okay, we will study that how does the electric current create the magnet actually. So the law of magnetism were failed. But when it was assumed that the direction of electric current is same as the positive charge, then all the laws of magnetism were passed. It means they just hold true when it was assumed that the direction of electric current is in this direction. So in this way we can say that the direction of electric current is opposite to the flow of electrons. It means the direction of electric current is this. Direction of electric current is this. So direction of electric current is this. It means direction of electric current is always from positive terminal to negative terminal outside the battery, but inside the battery negative to positive side. Okay, so this is the correct thing. Please draw this diagram first of all. This is very important diagram. Okay, so guys, this is the way the electrons flow in a metallic wire actually. Okay, these are the electrons, and these electrons flow from the negative to the positive side of battery, but the electric current flows from positive terminal to negative terminal. Actually this question is raised many times, that what is the direction of electric current in the circuit if a battery is connected. Then it is always said that the direction of electric current is always positive terminal to negative terminal, but this is outside of battery. But when we talk about the inside the battery, then the direction of electric current is always from negative side to positive terminal, because electric current always forms a loop. And that's why the direction of electric current is negative to positive inside the battery. Okay, so this is what we wanted to explain. Okay, so guys, just see one thing. that this is the method that the electrons starts flowing. But just imagine one thing. Imagine one thing. Suppose that this is the diagram. Suppose that this is the diagram, and the electrons are flowing, and the electrons are flowing in some certain direction. Okay, electrons are flowing in some certain direction, and suppose that these electrons will collide. These electrons will collide to the with the atoms, and when these atoms will collide with the atoms, when these atoms will collide, these electrons will collide with atoms. These electrons will collide with atoms, and some heat will be generated. Okay, then some heat will be generated. Okay, then these electrons will collide with atoms, and some heat will be generated. Okay, some heat will be generated. Some heat will be generated like this. Some heat will be generated. Okay, so in this way we can see that some heat will be generated, or heat generates inside the metallic wire when the electric current flows. Okay, when the electric current flows for some time, for the long time, some electrical machines burn out. Okay, just like the electric transformer, electric motor, and such type of machines. Okay, so this is the reason that the electric machines get heated after a long time of operation. Okay, so the cooling process, yeah, cooling system is provided by the for the machines. You can see in CPU or in laptops that there is a cooling mechanism. There is a small fan inside the laptop, inside the CPU of the computer system, that actually just withdraws the heat, okay, by the convection method, and that heat is just pushed into the atmosphere by the fan. Okay, so that the whole system remains at the very low temperature, no burning. Okay, and this is okay. As well as we see that these atoms with which these electrons collide, actually these atoms provide the hindrance to the flow of electrons. These atoms provide the hindrance to the flow of electrons. Okay, and since these atoms provide the hindrance to the flow of electrons, that's why this kind of hindrance is known as the electric resistance. That's why such type of hindrance is known as. Okay, so this is the reason that such type of hindrance, this is known as the electric resistance. If the number of collisions will be high, if the number of collisions will be high, it means the heat generated will also be equal to high. If the number of collisions is high, it means if the number of collisions is high, then if the number of collisions is high, then or number of collisions is high, then obviously we will say that the heat generated will also be high. Okay, it means these atoms will offer more hindrance to the flow of electrons. In this way, we can say that we can conclude that higher the electric resistance of the wire, higher the electric resistance of the wire, higher the value of electric resistance of this wire, higher will be the higher the value of electric resistance of this wire, higher will be the heat generated. It means the heat generated actually directly depends upon the electric resistance of the wire. Okay, so we will write the whole thing here. In a metallic wire, in a metallic wire, electric current flows. Electric current flows through. Electric current flows because of flow of electrons. Because of flow of flow of electrons. Because of flow of electrons. Okay, so when electrons flow, collide with atoms, collide with atoms and heat is generated. Okay, so these atoms offer hindrance to the flow of electrons. To the flow of electrons. Okay, to the flow of electrons. This hindrance is known as electric resistance. This hindrance is known as electric resistance. Unit of electric resistance is ohm. Unit of electric resistance is ohm. Okay, so unit of electric resistance is ohm. So guys, this is the basic theory actually. I will write some more things in next video, but you should write all these things today, and these are very important things, and I'm sure that you will get benefit of this session. And guys, so this is for today, and we will start again tomorrow again at the same time. And I'm sure that you are studying there, and okay. So guys, if you have any doubt or any problem, then you can just put your query into the comment option. Okay, I will try to solve it out as soon as possible, and share these session among all your friends. And if you have not subscribed this YouTube channel, then please do subscribe. And I come live at 10 a.m. in the morning and 2 p.m. in afternoon session. At 10 a.m. in the morning, I discuss some important questions, and at 2 p.m. session, I discuss the theory portion. Okay, so this is the routine. This is the basic routine. So, guys, let's finish. Okay, thank you so much. Have a nice day. Bye bye.